In this video, I want to have a look at equations that have pronumerals on both sides. So if an equation has a pronumeral on both sides of the equal sign, then our first step is to rearrange it so that they're all on one side of the equal sign. So we eliminate all the pronumerals on one side. Then we've just got a standard equation and we can solve it as we have been. So our first example asks us to solve 5x minus 8 equals 2x plus 1. So you can see that we've got x's on both sides of our equation. So we either need to get rid of this 5x off this side or the 2x off this side. It doesn't really matter which one you do, you'll end up with the same answer regardless. But it's usually nice to try and keep our x's or our pronumerals positive because they're a bit nicer to work with. So that means that we usually get rid of the smaller one. So because we've got a 2x is smaller than 5x, let's get rid of that 2x. So we'll subtract 2x from this side of the equation, which means we're going to have to subtract 2x from the other side as well. That's then going to leave us with 5x minus 2x is 3x, and we've still got that minus 8 equals just 1 on that other side. Then our next step to get that x on its own, it's just a normal two-step equation now. So we're going to add 8 to both sides of our equation, and we'll end up with 3x equals 9. And then we'll divide both sides of that equation by 3. And we'll end up with x equals 3. Remember, it's always a good idea to substitute your answer back into your question to make sure it makes sense. So x equals 3. If we substituted that into that side, we'd have 5 times 3 is 15, minus 8 would be 7. And if we substitute it into this side here, 2 times 3 is 6, plus 1 gives us 7 as well. So because we end up with the same value on both sides, that means our answer is correct. Our second example asks us to solve 7m plus 28 equals 9m plus 6. So this time we've got a 7m and a 9m. To keep things positive, to make it a little bit nicer for us, we're going to get rid of the smaller one. So we're going to subtract that 7m from both sides. And we'll be left with 28 equals 2m plus 6. Then we'll subtract 6 from both sides. We'll end up with 22 equals 2m, and then we'll divide both sides by 2. We'll end up with 11 equals m, and we usually just rewrite our answer so that our pronumeral's on the left. So we'll end up with m equals 11 as our final answer. All right, let's have a look at a few more. So question 3 says solve 13k minus 15 equals 3k minus 35. So again, we're going to get rid of the smaller one. So we'll get rid of that 3k. We'll subtract it from both sides. We'll end up with 10k minus 15 equals minus 35. So now we're aiming to get that k on its own. So we'll add 15 to both sides. So we'll have 10k equals now minus 35 plus 15 will bring us to minus 20. And then we'll divide both sides by 10 to end up with k equals minus 2. Again, with all of these, you can substitute back into the question to make sure it makes sense. All right, our last one, question 4. Asks us to solve 8w plus 3 equals 25 minus 3w. So this one's a little bit different because we've got a positive 8w and we've got a minus 3w. So this one's still our smallest, so we're going to get rid of that. But because it's a negative 3w, instead of subtracting it like we have in all our previous examples, we're actually going to have to add 3w to both sides. And the reason we do that is that if we had minus 3w plus 3w, that's going to leave us with 0w on this side. But we have to do it to both sides, so 8w plus 3w will give us 11w plus 3 is equal to 25. Then subtract 3 from both sides. We'll end up with 11w equals 22. And then dividing through both sides by 11. And we'll end up with w is equal to 2. So those are a few examples of solving equations that have pronumerals on both sides.